Hello, welcome back. So let's introduce the mint function first. So it is external function, so everyone can call it. And be besides the Swappi router, and any users can invoke it directly. So as for mint function, it will so the user has to transfer two tokens into the Swappi pair contract, and the mint function will mint the corresponding amount of the Swappi shares to the users. So first, use get reserves to get the reserve 0 and the reserve 1. Actually, they the contract can directly read the reserve 0 and 1. And then we will check the balance of the two tokens, because before running mint function, the users have to transfer some tokens into the contract, but the reserve 0 and reserve 1 haven't updated yet, but the balance is already there. So we can do subscription to get the users deposit how much amount of the two tokens. And based on the current reserves, we should mint a fee first. So and here is mathematical calculations to calculate how many fees to be mint to fee 2. So in this case, in Swappi, this case we will mint the 8 by 25 of the growth in square root of the k. So and here is the mathematical calculations. And if you're interested, you can put it in your note drafts, and try to scratch it and analyze it. But in anyway, so the liquidity will be calculated by the current total supply, and the difference between the square root k, the new k and the last k, the current k and the last k. After that, the liquidity is calculated and mint to v2. So which means whenever the users add the liquidity, the fee 2 will always get the fee in terms of the Swappi pair shares. And so that's for mint fee. And because we minted some liquidity, the total supply has changed. So we need to get a new total supply, the latest total supply. And note that if is 0, which means that there's no liquidity happened, no liquidity minted in mint fee, or there's no fee to set. We will first we will mint to address 0 with the minimum liquidity, just permanently lock it. Just make sure the pair has some liquidity. And if there is liquidity inside the pair, the two tokens has some price initially. And the liquidity. So normally the liquidity calculations is the square root of the user tokens input, and of course we will subtract the minimum liquidity because it doesn't belongs to the users. It's just locked in the contract. But what if the total supply is greater than 0? So we will check which is the minimum, and so the liquidity will be the amount 0 times current total supply divided by reserve 0, and check which the amount of the token ratio is the minimum from the user's deposit. So we define we calculate the liquidity and mint to the target address as the arguments in the function prototype. After mint to liquidity, we will update the current balance to reserve 0 and reserve 1. We'll go to the update. First we will update. So we update the reserve 0 and the reserve 1 with balance 0 and balance 1, and last block timestamp update is also updated, and we also calculate the cumulative price for token 0 and the token 1. Times times the time and use the ratio between reserve 1 and the reserve 0, or reserve 0 divided by reserve 1. So here we see we use a encode function, and yeah, and just make the mathematical calculations passed by compilation. So the price we know it's the instant price is just the ratio between the amount of the tokens inside the pair. But we calculate cumulative price, we need use times a 10 as LPS. So that's the calculation, and these two variable won't be used in anywhere in Swappi pair, but it will be used in some third-party price article to calculate the cumulative price. So this is read only, and we for external third-party contracts or third-party projects. So that's for updates. And if it's fee on, like if it's if there is fee is minted, we need update the last K variable to store it and make sure the next time to mint fee again. So we know the K is reserve 0 times reserves 1, and then we emit the mint. So that's for mint. And for burn is also external. And first we get the similar as mint. We will get a reserve 0 and a reserve 1, and token 0, token 1, and check the balance, current balance, and the liquidity. and check the liquidity, and this liquidity is the users sent to here before it runs the burn, right? And so it sends here, so there the current contract itself has some balance of the liquidity, and after that we will, so there is a, there is a yeah, there is dangerous here, because you need, so before you run the burn, you need to send the tokens to the liquidity. So you must guarantee the two steps, the liquidity transfer and the burn function steps must be in one single step, like in one single transaction, to make sure the operations are running atomically. So it's the same thing. We will mint the fee for burn, and check the total supply, and we will according to current balance, we will calculate the liquidity. We want to we will calculate the amount 0 and amount 1, and then we will burn. First, we will burn the liquidity for current contract itself, and then transfer the token to the target address for amount 0 and amount 1, and then we need update the balance, and then update the reserve 0 and the reserve 1. And also, if it's minted, it can be mint, we will update the last K in order to mint fee next time, and then we will emit burn event. So that's for burn. Next step is swap. So it's swap, from 0 to 1, from token 0 and to token 1, or token 1 to token 0. So here you must identify how much amount of token you want to take out. So generally you can specify a different amount of these two variables, but the Swappi router contracts will determine one of them must be a 0, but generally if you can directly invoke swap function, you can specify a different value of these two amounts, as long as you get the your amount in has enough amount. So first we will check is greater than 0, at least one of them, and check the amount is enough. So the required amount to go out will be enough for the two reserves. And then we will check first we will transfer tokens to the target address. And here is do the Swappi call. So after transfer, some users, do some operations. So if its data here is greater, the length is greater than 0, we will help it help the target address with wrap as the Swappi call E interface and call a function called Swappi call with several the required information. So if the target address is a contract address, and they need have exactly the same name of the function Swappi call. And if you're needed, you need provide the data, and if you don't need, just leave it as empty. So you can call and perform some operations when you provide some data. And here, no, it doesn't care about the it doesn't care about it cares about is success it reverted or it is failed or success. If it's reverted, it just stop it. And then we check the latest balance. Here we'll check the amount in. So the amount in is easy, also easy. Just check the current balance, compare when you goes out the remaining amount. So if there is, it will so it must be you know if there is some remaining here, you must be provide some token for amount 0. If it's less than that, that means you just borrow a small all of it. So or we can set it 0, and which amount 1 is the same as this. And but you just make sure one of them must be greater than 0, which means you must swap something. And then here is calculate will subtract the swap fee, and in Swappi there is 0.25% swap fee. So here it just do the deduction. And here is the important one. So because there's the Swappi router will check the K when you are after, so before you did swap, so they will the router will check the, so if you swap, the K must not should keep the same. Should should keep the same or greater than the original one, because we deduct some trading fee. And here we do the same thing. So we multiply these two, adjust the balance, and check the original K is correct, is greater, must be greater or equal. And the Swappi router wants to guarantee the K doesn't change. And then we will update the reserve 0 and the reserve 1, and then we emit the swap event. So that's for the swap. Then we will there is two public functions as well. So first is scheme. Scheme means so want to forces the balance to match the reserves. So someone can freely to get some balance. some balance of token 0 or token 1, just in case someone want to send the amount of the token 0 and token 1 to Swappi pair by in some mistake, and someone can get this balance freely. Also, we can do updates to force reserves to match the balances. So either way, either way is okay and is very healthy to keep the Swappi pair to running formally. So that's for the Swappi core. And next we will talk about the Swappi router.